G'day. From your lockdown to my lockdown, welcome. Here's Year 8 Algebra revision. So, let's start at question 1. Firstly, decide which of the following is true. Knock it off. Which one of them? Do I have any votes there? There's A that says x plus x plus x equals 3x's. There's B that says 8x take 3x is 5. C that 3x plus 5x is 8. D 4 times x equals 4x.
D.
It is indeed D. What you need to remember is that wherever you don't see a symbol, for instance, you see 4x, that means 4 multiplied by x. So wherever you don't see a symbol in algebra, it means multiplication. X, that's actually 3x, 3 lots of x. It isn't this, because if you see x together like that, it means x times x times x. It's very different. Addition and multiplication aren't the same. 8 lots of x take away 3 lots of x. That's not going to give 5. What should that give? What would 8... If you have 8 chickens take away 3 chickens, what do you have?
5 chickens.
5 chickens, right? Where'd the x go? Same with that one. 3x plus 5x equals 8. Where'd the x go? If I have 3 lots of x plus 5 lots of x, should be 8x. Anyway, the answer, 1 is D. Question 2. The worded statement x less than 7 is written in algebra as? X less than 7. So you're starting at 7.
C.
Yep. 7 take away x. Absolutely correct. And question 3. The expression 2x plus 4x can be written as... What's it going to be? Come on, Anthony. What's 2x plus 4x?
2x plus 4x.
2 lots of x plus 4 lots of x.
B.
It'll be? B. 6x. That's right. 2 lots of x plus 4 lots of x is 6 lots of x. 6x. Should we go down? Pause. And question 4. If n is equal to 3, which one's true?
Yeah.
It is? Which one? It is A. Because 7 take away 3 is 4. All the rest are wrong because 7 take away 3 is not negative 4. 22 equals 3 plus 18? No, 3 plus 18 is 21. And over here, the trick question, remember where you don't see the operation, it means multiply. 4 times 3, it's not 43. Right, question 5, 2x plus 3, where x is 6. Now we have to remember, there's no symbol between 2 and x, so it means multiply. So it means 2 times 6 plus 3. We do multiplication first. 12 plus 3, it is 15. It is C. Okay, now question 6, you need to remember some of your index laws. 2 to the power of 3 times 2 to the power of 5. The trick is that when you've got the same base, see that's what's called the base there, 2, you can actually add the indices. So what's 3 plus 5?
8.
2 to the power of 8. Now if you go and do that in painful detail with the numbers, like 2 to the power of 3 you're telling me is 8, 2 to the power of 5 will be 32, and that'll give you 256. You'll find that 256 is actually 2 to the power of 8. How cool is that? You can just add the indices in that situation, all right? So for you guys at home, 2 to the power of 3 times 2 to the power of 5, add the indices, you get 2 to the power of 8, which is D.
Okay.
All right, question 7, what's the same as 3 squared a cubed? Now what that, you need to realise that means 3 multiplied by itself twice, which gives 3 times 3. And this means a multiplied by itself 3 times, which means a times a times a. Which one does that give us?
A.
Option A. All right, for question 7, we've got to go in the opposite, question 8, we've got to go in the opposite direction. So in question 7, we had the index form and we expanded it out. Here, we want to summarise the expanded form with indices. So we look at it and we go, well, how many G's are there?
2.
How many H's are there?
2.
How many K's are there?
1.
And we don't need to write the 1 there because that's the same as 1 anyway. That's as much as it is, guys. How many G's? How many H's? How many K's?
And my pen.
Okay, now for question 9, it relies on remembering one of your index rules. What's any number to the power of 0? Do you know?
Dada.
Have a guess?
Dada.
No.
0.
It's actually not.
Nani?
It's 1. Yes,
That
we
was
have the
correct.
answer in the back. So yes,
Correct.
5 to the power of 0 is indeed 1. Notice that that's slightly different to, I'll give another example where it's a little bit different. If I had 3 times x to the power of 0, that x to the power of 0 would become 1, but the 3 would still be there. So be careful, you can get some slightly different questions in this area. Okay, so if the square root of this big number is 121, then what would 121 squared be? This relies on you recognising these things are opposites. It simply is that number over there. It's 14,641. Right? The opposite of square root is squaring. Cool? Do you want another example? Here. If we did the square root of 25, what number multiplied by itself gives 25? Anyone?
5 times 5.
Yeah, it's 5, right?
Correct.
And in turn, what's 5 squared? If you've got 5 times 5 is?
10.
Huh? 5 times 5?
25.
That's more like it, guys.
That's 25.
So they're opposites. See that? Square root of 25 is 5, and then 5 squared will give you 25 again. Go.
Times
Here we
1
go.
times
So-
1.
11, question 11. So we need to calculate this out. So what is 2 squared?
4.
Yep, 2 times 2 is 4. What is 1 cubed? Yeah, it's just 1. 1 times 1 times 1, it's still 1. And then what's 5 to the power of 1? It's just 5. Yep, don't overcomplicate. And then what do we get, guys? Who's the first? 4 times 1 times 5.
20. Anthony. You just yoink the 1 out of here.
All right, question 12. 2 to the power of 2, all to the power of 3. Another one of our index laws, when you have a power to a power, you can actually multiply the indices. So what does that give us? 2 to the power of?
3 to the power of 3.
What's 2 times 3?
5.
6. That's right, 2 to the power of 6. That's all we're after there. So index laws, power to a power, multiply the indices. All right, question 13 relies on you having good understanding of like terms. Like terms have exactly the same letters and powers of those letters, right? You can only add or subtract terms. These things are all terms. You can only add or subtract them if they have exactly the same variables on them, right? So these two here have G in them. That means you can combine them. These two here have H. That means you can combine them. So what does that mean we're going to get, guys? What's 2G plus 3G?
5G.
5G. And what's H plus 5H?
8H. 6.
6H. That's right. H by itself is just 1H. So 1H plus 5H, 6H. Second one here, we've got stuff with X in it. We've got a Y and, we've got something with no algebra at all there, just a 2 on the end. That can't be combined at all. So the other important thing to remember when you're dealing with algebra at this level is negatives always belong to what follows it. So you see that negative sign there, the takeaway sign? It belongs to the 3x here. So what's 7x take away the 3x?
7x take 3x.
Yep.
5x.
7 take away 3?
4x.
4x, that's better. And we still have the 5y and we still have the 2. The negative there only belonging to the 3x. James swims y lengths of a pool. Sandra swims 6 more lengths than James. Represent the number of lengths Sandra swims as an algebraic equation. Yep.
What? 6y. Why
Oh.
6?
That would 6y would be if Sandra swam 6 times the amount that James swam.
6 more.
You're on the right track though.
Y 6.
Y, it's not multiplied, it's
Division.
6 more.
Y 7.
It's just more. So if I say I'm 6 years older than you, what would you do? Add, subtract, multiply, or divide? Yeah. So Sandra swims 6 more lengths than James, so it's going to be Y plus 6. That's all. You tried to overcomplicate that, didn't you? You just broke the clip. Well done. All right. Now question 15. Question 15, there is an infinite number of things you could put as answers to this one. So you're starting off with 5a plus 4, sorry.
Oh, Mino.
We've just got to write it in different ways. Yeah?
That's easy.
Yeah, so like you can write, the one they've given there is 5a plus 4a plus 4b plus 2b, because that'll be the same. Yeah?
6b, 9b.
Over 6a.
Yeah.
Well, if I started with 6a, then...
4b, 2b. No.
You're going to write it the other way around, are you?
1 sec.
Just a sec. I'm just going to put some examples up, okay? So 9a.
Me got one.
Okay, well, quick, give me one.
2b plus 2b plus 2b plus 2a plus 2a plus 3a plus 2a.
Oh, really? Plus 2a plus 3a plus 2a. Does that work? 2, 4, 6 lots of b. 2, 4, 7, 9 lots of a. Yeah, that works. Really, you can write all sorts of things here that'll still work, okay?
And I still got
So, you know, 7a plus 2a.
I got another
plus
one.
6b even.
Dada.
Okay, last one.
3a plus 6a
Yeah.
plus 3b plus 1b.
Oh, we still need another 2b to make that.
Plus 1b plus 1b.
No, I made it 2b. Anyway, as you can see, there is an infinite number of options for this question, as long as in the end it gives you 9a plus 6b. Okay, question 16, the distance around this object. Please stop bumping it. Right, so perimeter is the sum of the sides. What are the sides? 7y.
And 4y.
And 4y, and they're both there twice. Remember, perimeter's distance around the outside. So you're going to have 7y plus 4y plus 7y plus 4y.
Wait, you're
and all that. Yeah, it's the distance around it. And what did you get?
22.
22y.
I do perimeter at school,
Yep.
Dad.
11 plus 11. Yep, definitely 22y. Alright, question 17 guides you on solving a two-step algebra question. Starts with this problem. 5x take away 5x plus 2 is 32. Now, what's the first thing you do in two-step algebra with a question like this? Peanut gallery?
Peanut gallery? I'm not a peanut gallery.
Alright guys, hey, for the record, do your addition subtraction first, right? What's the opposite of adding 2?
Taking 2.
Taking 2. So we're going to get 5x is equal to 30. And again, we're thinking about opposite operations here. What does that mean when you see 5x? It's 5.
Times.
And what's the opposite of times? The opposite of what?
Divide.
Right? So what we actually do then is we divide both sides by 5, as the question actually gives that away to you. But the reason we're doing that is it is the opposite of multiplication. And that leaves us with x is, what's 30 divided by 5?
30 divided by 5 is 1.
Huh? How many 5s are in 30?
Oh, yeah. 6.
That's more like it. X is 6. So if you put 6 back in here, that should work now. 5 times 6 plus 2 should give 32. Works to me. I'm happy with that. How about you?
Yeah.
We'll do question 18 at the same run, right? Same sort of thing. 4x is 20.
Yeah.
Given that's currently multiplied, what do you think I'm going to do to get rid of that 4? Yep. I divide both sides by 4. Leaves me with x is 5. Simple as that, because 4 times 5 is 20, isn't it?
Yay.
Yeah, so that one's correct. Already done. Okay, so the idea of question 19, this picture, is that is meant to be equal to that. They're meant to be the same weight. So how many lots of x are over there on that side?
2.
So we can see there's 2 lots of x. So 2x and plus 6. That's right. 2x and 6 is on that side is equal to 14. So that's your equation. You're just meant to look and go, oh, 2 lots of x and 6 is going to be equal to the other side, which is 14.
What
First
X
step.
is?
What is it?
X is...
It is 4, but we're going to work it out properly. What's the first step here? What did I say we did first?
2 plus 4, technically.
We do our addition subtraction first. How do we get rid of a plus 6? Take 6. So what you'll see me do is we take 6 from both sides, because that gets rid of the 6, doesn't it?
Yeah.
That leaves us with 2x on this side, and what's 14 take away 6?
8.
Yep. And now what am I going to do next? How do I get rid of the 2?
Take 2.
No. It's currently multiplied. So what do I do to get rid of the 2? That's right. We do opposite operation. And what does that leave us with? X is
4.
what you told me it was earlier. Okay? And you can always check that by putting 4 back into the original equation if you want. So there we go. That's question 19. Okay, question 20 and 21, we're going to do expanding. So, expanding means what? Getting rid of brackets, right? So the whole idea of expanding is we're going to get rid of those brackets. Now what you need to remember is to multiply what's on the outside by everything that's on the inside. So 3 times x, and then plus, what's 3 times, plus 3 times 4. They're doing it in detail. What is 3 times 4? 12. That's the answer. So expanding, just remember to multiply what's on the outside by everything inside. That leads into question 21. Who's brave? Who's going to tell me the answer to 21 given that?
Just
3 times n is?
3 times m.
We just write it as 3m. We don't need to write the multiplication sign, remember? And then what's 3 times 2?
3 times.
Yep.
6.
That's right. So the answer is 3m plus 6, okay? So again, multiply what's on the outside by everything on the inside. All right, question 22 and 23 are asking for you to do factorising. Factorising is the opposite of expanding. Expanding gets rid of brackets. Factorising puts in brackets. To do factorising, you've got to first look at what you've got and think, what's the biggest thing that goes into both of them? The biggest number and biggest variable if they have variables in common. What is the biggest number that goes into both 8 and 14?
8, 4.
Biggest factor
Oh, biggest factor.
that goes into both 8 and 14.
7.
7 doesn't go into 8.
No, 7.
Ah, but what's the biggest one they have?
Dada!
What's the biggest one they have in common that they both have?
2.
Yeah. And that's why in their solutions, see how they had the 2 at the front? And now we have to think, 2 times what gives us the 8a? And they've already told us that's 4a. And then we have to think 2 times what would give 14b?
7.
7b. There we go. So that's it. It's finished. Now let's look at the next one. Question 23. 9c, take away 6w. What's the biggest number that goes into both of them?
3.
3. And there's no letter in common. If there was a letter in common, we'd take that out as well. But anyway, that tells us highest common factor, biggest thing that goes into both is 3. That goes outside the brackets. Then we have to think 3 times what gives us 9c?
3 times what? Oh, 3.
Yeah, 3 times what gives us 9c?
3 times 3.
Yeah, it'll be 3c. And then 3 times what gives us 6?
2.
Yeah, so it'll be take away 2w. See? So that's year 8 maths though. You need to actually practice that a lot. All right, so question 24. Represent the perimeter of this regular octagon. How many sides does an octagon have?
Isn't it 12?
No, that's a dodecagon.
Oh yeah, 8.
Yeah. Octagon's only an 8-sided thing. So represent the perimeter of this regular octagon using algebra.
Oh, God.
So it's going to be x plus x plus x going on, isn't it?
Yeah, that's going to be annoying.
Annoying, yeah. So what's an easier way of writing x plus x plus x plus x 8 times?
1, 1, 1, 1, 1, 1, 1, 1, 1, 1. No, 8.
8x. It's just 8 lots of x, isn't it?
Yeah.
That's your perimeter. And then for part B, it says each side length is double. What do you think the perimeter would be if each side length was doubled? Well, each side length, instead of being x, is now going to be 2 lots of x.
So now is it going to be 16x?
I sure think so. So when it's doubled, well, we could write it as 2x plus 2x a number of times, couldn't we?
Yeah.
Bit painful, isn't it? We don't want to write that 8 times. How many times have I done it now? 7? But yes, it will be 16x. It's going to be double what the original one was, with every side being twice. Cool? And now for question 25, we have a rule. The rule states that y equals 3x plus 2. And it says, well, what's the value of y when x is 3? So we need to put the value of 3 in as x. What are we going to get, Anthony? If x is 3, what are we going to get?
X.
So that's equal to 3.
33.
No. Anthony.
9.
Yep. So, but we know that where we don't see a symbol, it means multiply. So it's 3 times 3 plus 2. Now, what is 3 times 3?
Wait, I thought it was 3 threes.
Yeah, 3 threes. It's 9.
Okay.
9 plus 2. Come on, everyone. 9 plus 2. 11. Thank you. Now, for B, enough. For part B, it says to put in different values of x. So, tell me, if x was 0, what would we get?
Well, it would be first,
Be 3 times 0
which is 0,
plus 2, leaving us with?
2.
Yep. When x is 1, we'd get 3 times 1 plus 2.
5.
We get 5. 3 we've already done. I'm going to just put the value we had above. And the last one says if x is 5, what would I get?
So that would be 15, 17.
15 plus 2 will be 17. And there we go. We've completed the table. Okay, question 26. Mia buys 5 pens and Bob buys 3 of the same. The total cost is $16. Decide on a pronumeral to represent the cost of 1 pen. Shh. Pronumeral simply means variable, a letter. What letter do we want to use to represent the pen price? P for pen? Right, we'll let P be the price of 1 pen. What's price measured in? What units? Dollars. All right, put your legs down so they can see the thing. B, create an algebraic equation to represent the relationship between the cost and number of pens. So Mia bought 5 pens, so that would be 5p. Bob bought 3 pens, so that would be?
That's 3p.
And the total cost is?
8p.
What was the cost?
16.
Yeah, that's the situation, yeah. And in terms of, you've already gone ahead to the next part of it, which is solving it, right?
Yeah.
People got to see the board. If I'm solving that in part C of this question, what is 5p plus 3p?
8.
Yep. So 8 pens was $16, right?
Yeah.
And then what do I do to get rid of the 8?
Divide or
That's right.
times?
It's currently timesing, so we do the opposite, which is divide. Always do the opposite operation. And what's 16 divided by 8?
2.
2. And if we're doing this all properly, at the end we'd write a sentence and we'd say each pen is $2.
Yay.
Yay! All right, on to the B level here. Question 1, so we're on page 6 now. Use words to describe the operations on P. So you see this fraction P over 7. What operation is the same as that? It's division. So here P is being divided by 7. And then what are we doing? Subtracting 5. So you write something like P is divided by 7, then 5 is subtracted. That is the story of what P is enduring today. Question 2. 2 relies on, again, you understanding like terms. So like terms, not only do you have to have the same variable, but you need to have the same powers of those variables. So in this case, 11t take away t squared, take 3t plus 6t squared. We've got two things that have just t in them, and we have two things that have t squared in them. You can't combine all of them. You can only combine the t's with the t's and the t squareds with the t squareds. So 11t take away 3t will give us 8t. And this is where you've got to be very careful with negatives. Remember, that negative belongs to that t squared there. So it's a negative t squared plus 6t squared. If I had negative 1 and add 6, I end up at positive 5. So it will be plus 5t squared. And 2b then is multiplied. Now with addition and subtraction, you've got to make sure you've got like terms. With division and multiplication, you can pretty well do anything. So 5x3y squared times 3x4. I mean, in effect, it's multiplication between all of these different bits. I mean, if you wanted to write it out in more detail, you could write it as 5 times x3 times y2 times 3 times x4. Right, what can you combine there? I can see a 5 times 3. I can definitely do something with that. 5 times 3 is 15. I see an x to the power of 3 times x to the power of 4. What do we do when we multiply things like that? Do you remember from earlier? You can add the indices. So there'll be x to the power of 7. 3 plus 4 is 7. And we've got a y squared there as well that we haven't included. So that's your full working if you wanted to see it. I'd be happy if you went from this step to this step. I only showed that step because I think it can help with the understanding. All right, on to question 3a. Now 3a is all relating back to that idea that anything to the power of 0 is 1. So here, everything in the brackets here is being applied to the power of 0. That means the whole lot of it is simply 1. But over here, only that power of the 0 only applies to the y. So you notice here, that power of 0 applies to everything because of the brackets. But over here, that 0 only applies to the y. So y to the power of 0 is 1, but it doesn't impact on the 4. We still have the 4 there. So it's going to be 1 plus 4. The answer to that is 5. Second question, very similar to one we did earlier. When you have a power to a power, you need to multiply the indices. So that's going to give us c to the power of 8. 4 times 2. All right, this here, question 4 says expand everything and simplify where possible. So I'm doing my brackets there so you can see all the work. So 4 times 2h, 4 lots of 2h is 8h. 4 times 3 is 12. 5 times 10 is 50. 5 times negative 4h is negative 20h. You can then combine some things. You've got stuff with h's, and then you've got pure numbers that you can combine as well. 8h take away 20h. That's not very nice, is it? That's going into the negatives. You'll end up with negative 12h, and 12 plus 50, relatively easy that one. It's simply 62. Hopefully that's correct. Yeah, looks pretty good from here. Question 5, is a factorisation problem that I've now written up here. 22 CD subtract 33 CE. Now, what's the biggest thing that goes into both of these? Remember, factorising means putting in the brackets. To put in the brackets with the highest common factor, biggest thing that goes into both parts. Now, I can see there that 11 actually, 11 goes into both of those numbers. And they have a letter in common as well. So that letter, the pronumeral, becomes part of the highest common factor. They have a C in common. So the highest common factor is 11C. That's going to be outside the brackets. We have to work out what's inside the brackets. 11C multiplied by what gives 22CD? That will be 2D. And 11C times what gives us negative 33CE? That will be negative 3E. You can always check these again by expanding. If I expanded what I just wrote, will I get what I originally had? I believe I will. I would get 22CD take away 33CE. It definitely works. Right, question 6 says an expression starts at 6x plus 12x squared plus 18x cubed. Infer the value of the coefficient of the sixth term. Coefficient means the number in front. So the coefficient of the first term is 6, the second term is 12, the third term is 18. So what's happening each time? I hope you realise it's going up by 6. So if I look here, the first term is 1 times 6, the second term is 2 times 6, the third term is 3 times 6. So if I wanted the sixth term, I believe that would be 6 times 6. What's 6 times 6? 36 will be the coefficient of the sixth term. Question 7 says the area of a rectangle is 25 metres squared, and they give you a box here where one dimension's A and one's A take away 3, and it says create an algebraic equation in terms of A. So to do that, you need to remember, how do you work out the area of a rectangle? How do you work out the area of a rectangle? What's the formula for area of a rectangle?
You times all things, because it's all the same.
Length times width.
Oh yeah.
So for this particular case, it's a little bit weird. The area they've told you is 25. The length on the diagram is showing as A, and the width is showing as A take away 3. Now I needed to do the brackets there because otherwise it would mean that A was only multiplied by the A. But no, the width is A take away 3. You need to multiply it by the whole of A take away 3. I didn't need to write the multiplication symbol there. We could write it as that. And look, if you wrote it this way around, this is also correct. If you wrote it the other way around, it's still the same. It's just the sides have been flipped. Either way, that's your algebraic equation for that area question. Okay, question 8. Solve the following equations. So when you've got brackets like this, you need to expand first. So this is question 8. 4 times x will give you 4x. 4 times negative 1. 4 times negative 1? Negative 4. And now we're back to the equation that looks very similar to some of the ones we did earlier. First we do our addition and subtraction. What's the opposite of taking away 4?
Plus.
I add 4 to both sides. And I'll get 4x is 26. This isn't going to be precise. The opposite of multiplying by 4? Divide by 4. So x is going to be 26 divided by 4. What is 26 divided by 4?
Oh, 1 sec.
It's going to be 6.5. 6.5, isn't it? 6.5?
6, 12. Yeah.
Yeah, 6.5. You're allowed to use calculators on this one, actually, so you could have chucked that in your calculator. You could have put 26 divided by 4. But it's more fun to do it without a calculator, though.
Yeah.
Okay, and the last question here, question 9, shows a graph of y equals 3x take away 5. and it says use the graph to solve the equation 1 equals 3x take away 5. Now firstly you're going to need to remember what y and x mean on these things. X is always the horizontal axis, so this is the x-axis here, so that means x is 1, 2, 3, 4, 5 along there. The y-axis is this one up here, so that means y is 1, 2, 3, 4. And it's essentially put 1 in place of y. So where is y equal to 1?
Y equal to 1 down there.
Here, right?
I'm
So
actually doing this stuff.
all along here, y is equal to 1, all along that line. Where does it run into our equation?
Here.
Where does it run across our line? Here, right? That's where it hits the line. So what's the x value there?
2.
Yeah. So essentially, when y is 1, x is 2. And in this question it says construct line markings on the graph to identify how you used it. Well, that's exactly what you do. Draw a line where y is equal to 1, see where it cuts across your line, look down, tells you what the x value is. That's exactly the sort of lines that would be expected for that question. Right. All the best for your study. I hope that helped.
Bye.
Bye.